Hey guys, welcome back to Statistics Explained. In this video, we're going to solve some numerical problems on chi-square distribution. So let's get started. The first problem I have here is about finding out the 95th percentile of the chi-square distribution where degree of freedom is 10. So for solving this type of problems, we need chi-square table. We will go through the table and check what exactly is the value of chi-square given that the area to the left of the value is 0.95. So if I just show you graphically how does it look like, I will have this as a chi-square distribution, and here somewhere I will have the 95th percentile. So the area to right of it will be 5%, and I will have some chi-square value here which I need to actually find out from the table, given that the degree of freedom in this case will be 10, and here I will have the probability density. So this is just the graphical look of this, and if I go through the table and solve this, so let's go through the table and find out the 95th percentile at degree of freedom 10. So I'll just hide this, and I have chi-square table here. So if I go here and just check at 10, the values are these. Now I have to actually find out the 95 percentile. So at 95 percentile, the value will be 18.307. Now why 18.307? Because I have the 5% area which I showed you graphically in this case. So I have this 5% area in this case. That is why we are going through the values, and the value will be 18.307 for this one. Let's move to the next one and see. So in this case, it says fifth percentile of the chi-square distribution at same degree of freedom. So if I have to find at the same degree of freedom, I will again have my chi-square distribution. This will be 10. This will be again my probability density here, and I will have chi-square value here which I need to find from the table. But in this case, I will have the value here which is the fifth percentile. So I won't have this as an upper bound, but I will have this as my lower bound. And since it says the fifth percentile corresponding value for the distribution, it is the chi-square distribution to the left of 5%. So if I have to go through the table back and find out this value, so I'll just hide open board and I will again open the table. Here if you see, I have degree of freedom 10, and I need to find out the fifth percentile, which will be this one. Since I have to find it to the left, we are going for 95 here, and the value will be 3.940. So I'll go back here and I will write down the answer, which is 3.940. Alright, let us move further and see the next one. So in the next one, it says I need to find out the probability that chi-square lies between these two values, and I have been given the degree of freedom. So if you understand this one, it will say this is if chi-square table with degree of freedom 22, then one value will be here, one will be here, and this will be my lower bound, and this one will be my upper bound, and these values are chi-square value, and I need to find out the probability that chi-square lies between these two. So in order to solve this, I have to again go back to the table and find out the percentage of the distribution below a specific value, and then I have to use interpolation, in this case approximate values, in order to arrive at the answer. So let's go through the table and try to find out the value which is closer to 10.98. Alright, so I'll just hide open board and I'll come to the degree of freedom which is given to us in the problem as 22. So I'll come to 22 and I'll try to find out 10.98. So I can see chi-square distribution is near to this one. So the value closer to this one is 10.98, but since I have to find out the values in between, I'll go for approximate, which is 12.38, and this is close to my 90%. So I can say this is 90th percentile around, because this one and this one are the interpolation figures. So I can say since 10.98 is in between these two, it can be around 85 to 88%. So I'll choose around 88% for this one. And next, if I have to find out the chi-square value for 36.78, which is my another figure, then I'll just move a little further here and I'll see it is on the chi-square value 0.25. So I can see that is around 0.975, 97.5% of the area. So if I just go back and solve this and execute all the values, then let us see how will it look like. So I'll just go back here and I'll come to open board. Here what I'm going to write is P 10.98 chi square 36.78. Here I'm going to write P chi square less than 36.78 minus P chi square less than 10.98. And since I have figured this out as 97.5, I can write this as 0.975. And this one, because I have mentioned that it is between 85 to 88%, so I'll just write 0.88. When I'll solve this, this will come out to be around 9.5%, or I can say 0.095. All right, so this is how you solve this one. And similarly, I have part D. So let's try to solve that one. So if I read through part D, it says probability x square should be less than and it could be greater than also. So in this case, what will happen is I will have my chi-square distribution at 25 degree of freedom. I will have my lower bound, I will have my upper bound. But the thing is, I need to find this area in this case, since it could be less than or it could be greater than. So I need to find out this kind of area, and I will again have my values as 14.611 and 37.652. So ideally what I can do is I can actually use 14.611 at one point and subtract it from 1, and I can get the area below this lower tail, and then for the upper bound I can repeat the same process and I can get the value for the upper bound also, and then I can sum those two up. So let's go to the table and see this. I'll just hide open board and come to the table. So we will come to the degree of freedom at 25, and here I will see through the values. So if I see here 14.611, this is coming at 0.95, and again if I see the other one which is 37.652, this is coming at 0.05. So what I'll do, I can actually use this value and the other one to come at the answer. So what I'll do, I'll go back to open board, and here since I can subtract 1 minus the value I'll get for 14.611, which is 0.95, and then I can add to it the value I'm getting for 37.652, which is again 0.05. So I can write 0.05 plus 0.05. So the solution for this one will be 0.10, or I can say 10%. All right, so that is the solution for this one. And let's move to the next problem for chi-square distribution. So the next problem talks about the amount of lateral expansion, and it has given us the value of n as well as a sample standard deviation, and it's assuming normality and asking us to derive confidence interval for population variance and standard deviation. So if I just write down the formula which is used to find out the confidence interval for population variance, then it is always n minus 1, and this is always in bracket with the sample standard deviation square, and here we have chi square. Similarly, we have n minus 1 s square, and here we have chi square with the lower bound condition. All right, so in this problem I have been given n as 9, I have been given sample standard deviation as 2.81 mils, and also I have been given the value for alpha, which is going to be 5%, since I have to find at 95% confidence. So I will have chi square alpha by 2, which means I will have chi square at 0.025 for my upper bound, and I will have chi square 1 minus alpha, that is going to be chi square at 0.975 for my lower bound. All right, so now what I'm going to do is I am going to actually put this value and find out the answer through the table. So I'll just go here and I will hide open board. Also, the one important thing which I have to mention here is, since we are going for sample standard deviation, my degree of freedom in this case will be 9 minus 1, that is n minus 1, and it is going to be 8. So I am going to look at the table where degree of freedom starts from 8. All right, so I'll just hide open board and I will come to the table. I have to go through this row. All right, now the thing is, since I have to actually find out the value at my 0.25 and 0.975, which is my upper bound and lower bound. So the first one will come out to be my 2.18, which is this value, and for another one I have is going to be 17.535. All right, so these are going to be my two values. So I will go ahead and put these value into the functions. So I'll say this is going to be my n minus 1, which is going to be 8, and here I will have 2.81, and here I will have 17.535, and here I will have 8 into 2.81, and in this case I will have value 2.1 second. I just forgot this one. So this was 2.18. All right, so this is going to be 2.18, and once you solve this you will have your limits. So this will come out to be your lower limit, and this will be your upper limit. So, and once you get these upper bound and lower bound, you just have to square root them, and once you square root them you will get the values of your lower limit and upper limit for your standard deviation also. All right, so let us move to the next one then. The next problem talks about type 1 and type 2 error. So in statistics, what actually happen is we always make the answer based on the sample and we never observe the population. So just in case if some production is happening and we take a random sample of 30 to 40 objects of that production item, probably jeans. So we actually conclude that the jeans are of this type and their total length is this much or their width is this much based on the sample. And then we conclude that all jeans of the same size will be produced from the machines. Sometimes it might happen that the genes might have some different alterations as compared to what we actually forecasted for the entire sample, but that is what actually the difference between the sample and the population. So that is the theory behind type 1 and type 2 error. And if I talk about this problem is actually talking about a hypothesis situation which is actually revolving around the mean temperature of the water discharge from a power plant to the river. Now the problem says that if the temperature of the water is more than 150 degree Fahrenheit, then it violates the regulation and the authority wants the temperature should be equal to or less than 150 degree. Alright, so in this case what we have to do is we have to find out the type 1 and type 2 error. I will talk about the type 1 and type 2 error theory also, but the first thing here is to actually forming up the hypothesis. So in this case, whenever I have a problem like this, I will always say the null hypothesis will be assuming that the population mean is 150 degree Fahrenheit. This is suggesting that the mean temperature of the water discharge is 150 degree Fahrenheit, meaning the plant is in the compliance with the regulation and it is not violating anything. In the alternative, I will assume that the authorities is actually giving some written regulations to the plant, but the plant is actually not following them. So if it is not following them, then I will say that the population mean of the water being discharged is greater than 150 degree Fahrenheit. This is actually suggesting that the mean temperature of the water discharge exceed 150 degree Fahrenheit, which is actually a violation to the authorities. Alright, now let's come to type 1 and type 2 error. What are these cases? So when I say there is a type 1 error, it means that I have rejected the null hypothesis when it is true. So I'll just write this down first. Rejecting null when it is true. It means that the water which is being discharged was actually around 150 degree Fahrenheit. But what sample I took, it actually says that this is more than that. So the plant was actually following the regulations, practices, but based on the sample I collected, I actually concluded that the plant is not following the regulation practices, and that is why I actually created an error in my judgment. That is type 1 error. Similarly, I have another way of doing things which is type 2 error. So type 2 error is actually failing to reject H naught when alternative is true. So I actually fail to reject null hypothesis in this case. So for this problem it implies that if I actually make a type 2 error, then I will conclude that the plant is actually following the regulation. However, the plant is not following the regulation. So these two type of error I can do. Either I can conclude that plant is actually not following the regulation, and then I actually end up with type 1 error. Or I can conclude that plant is actually following the regulation. However, it is not following. So I created a type 2 error. Now let's come to the last part which says which type of error would you consider more serious. So just suppose if I do type 1 error, what will happen? I will say that the sample size I collected is suggesting that plant is actually not following up the regulation. However, plant was following. So what will happen is the authorities will issue more guidelines or do further studies on the plant, and based on that they will actually come up to the conclusion that plant was actually falling, so things will go smooth. What will happen if I do type 2 error? Now in type 2 error I will actually not reject the null hypothesis, so I will say that plant is actually following the regulation. So what authorities will do, they will say okay, if it is falling, let it follow. In this case the authorities will give it a permission that because it is following the regulation we cannot actually stop the plant. So what will happen, there would be more environmental damage. Since I could have stopped the plant, but based on my sample size and study, I actually concluded that plant is actually following the regulation, and that is an error on my part. But then the environmental damage will happen. More water will be discharged, which has the temperature more than 150 degree Fahrenheit. All right. So there would be highest environmental damage. So which type of error would you consider more serious? In this case, you can say type 2 error is more serious. All right. So that is all for this problem. Let us proceed to the next one. So the next problem, it talks about actually finding out the sample, and we need to check whether this is coming from the normal population. So in order to check whether a sample is coming from the normal population, either we can do a normal probability plot, or we can use a formal method which is Shapiro-Wilk test and check for normality. However, there is no specific method mentioned in this problem, and the next part of the problem is asking me to find out the upper confidence bound for the confidence interval of 95%. So what I'll do is I will actually check whether the sample has come from the population using the normal sample mean. So in case if this sample is coming from the population, then what will happen is the mean and the median of this sample should actually be coming out to be equal, or probably they should be closer to each other. I can clearly see the sample size is not more than 30, so I cannot actually use central limit theorem here. So what I'll do is I will sort this data and then try to find out its mean and median. So if I have to sort this out, I will write 33.2, and the next one will be 35.2. Then the next one again will be 35.2 only. So I'll write that one, and then after this the next one will be 35.8. Then I will write the 36, 36.2. Then I will write 36.7 and 36.7 again. Then there would be 37.3, 38.9, 39.1, 40.1, and then it will be 40.2, 41.8, and 41.8. All right. So these will be the values, and these values actually show me that the distribution is going to be more or less symmetric, although not perfect but symmetric. Then I will use my formula for mean. So it should be x bar by n. So I will sum these up all, and then I will divide it by the value coming out to be. So this is going to be 12 and this is going to be 3. So 15. And once I sum them up, they should come up to be somewhere around 598.2. So my sample mean will be approximately 39.88, and since this is coming out to be 15, the value for median will be, in this case, would be 37.3. So I can say these values are coming from near to normal distribution. All right. Then moving on from there, what I can do is I can actually calculate the sample variance. So I will write S square here and I will just write down the formula. So it is going to be xi minus x bar, which I just calculated. It has to be sum of it, then n minus 1. So I can actually use this value and this value. I can find out the difference and then I can sum them up. So for each value, you have to find out the difference and sum that up, and you have to divide it by 14, since 15 minus 1 is 14. So once you have this data and you sum them up, this will come out to be somewhere around 102.89, and once you solve this you will have 7.35 as your sample variance. Now the thing is, you need to find out the upper confidence interval for the standard deviation. So what I'll do is I will just find my standard deviation from this one, and this is come out to be 2.71. Now the next will be to actually write down the upper bound formula which we used in the previous question also. So this is going to be n minus 1 s square chi square by alpha by 2. But in this case, since I have to only find out the upper bound, so I'll just can actually write down here chi square alpha. All right. So this is going to be 14 into 2.71, and here I have to write down the value for chi square. So I'll just go and see this value from the table. So I have already come to the table. Here I have value of 14, and this is going to be 5%, that is 23.685. So I will just go to open board and I will add here 23.685. Once you solve this, you will have your upper bound. The only thing is, you need to remember that I have put here standard deviation because you need to find the upper bound for standard deviation as mentioned in the problem. All right. So yeah, that is all for this question. Let us move to the next one. Alright, so the next problem talks about a manufacturer of college textbook which is actually interested in estimating the strength of the binding produced, and he is using a particular machine for doing that. However, he actually is telling us that he need to find out how many books should be tested to estimate the average force required to break the binding to within 0.1 lb with 95% confidence interval. And he is saying, assume that there is a standard deviation which is known to be 0.8. So in this case, what is actually happening is we need to find out the margin of error. So I'll tell you some theory behind the margin of error and how exactly you can arrive it. So before moving to that one, just consider this one, that the confidence interval for the mean, how exactly they are derived. So if I have to determine the confidence interval for a mean, what I'll do is I'll take sample mean and then I actually take plus minus the value of the Z score corresponding to that confidence interval. Suppose it is 95% confidence interval, then in that case Z score is always 1.96. In addition to this, I'll just multiply this value with the population standard deviation, and then I actually have root n here, which is the sample size. Now what is actually happening when we have a margin of error, it actually tells us the amount by which we expect our estimate to differ from the true population mean. So this confidence interval give us some range for this population mean, and the margin of error tell us that what exactly is the amount by which our estimate differ from the true population mean. So suppose true population mean was 10 and my x bar, that is my sample mean, turns out to be 8, then margin of error is the amount by which it differs. So In this case, it will come out to be 2. So this is straightforward theory for margin of error, but how exactly it is calculated? So margin of error has a formula where E actually represent the margin of error. Z again represent the sample score, which was it representing in confidence interval as well. And then we have here the population standard deviation and root n. So this is very similar to the formula for confidence interval only, just that we have actually replaced this with the idea that this will differ from the population mean, and that's why we have our margin of error. So in this case, if I have to actually solve this up, I can say this is going to be E square, this is going to be square again, and this is going to be square, and this is going to be n. So I can write this as z square into my standard deviation of population divided by margin of error, and here I will have the actually the sample size which I need. So I can again write this as corresponding score of z, and then population standard deviation, E stands for error, and square of this, which is going to be my sample size. All right, so that is how actually you calculate sample size given the margin of error. So in this case also we have to use this idea and we have to arrive at the solution. So what I can write is, in this case my n, which is going to be books, will be equals to the corresponding value of chi-square, and it is going to be alpha by 2 because I have been given 95% confidence interval, and this is going to be my population standard deviation, and then the margin of error, which is 0.1 in this case. All right, so this is going to be square of that. So I'll just write here n, and I will just substitute this with 0.1. I have a square here, and I have given this value as 0.8. All right, so what is left here is I just need to find out the value for the z given alpha by 2. All right, so in this case, since I just mentioned that z square is always 1.96 for my normal probability plot, I can actually write here 1.96, and because I have got this value, you just need to solve this up. So this is come out to be 15.68 by 0.1 square, and once you solve it, n should come out to be 245.3 approximately. So I can conclude that he need to actually get 246 books, and these two should be tested to estimate the average force required within the margin of error of 0.1 lb at the confidence interval of 95%. All right, so yeah, that is all for this problem, and this was the last problem for this video as well. So if you like this video, please share it with your friends and subscribe to our channel. I'll see you in the next video then. Thank you.